All right, so let's talk about this table a little bit. We've got the year and then the nuclear waste, waiting storage in that particular year in thousands of metric tons, so save us writing a few numbers out. But here's what we want to do. Let's let x equal 0 represent 1995, which would mean then if x equals 0 is the 1995, then x is 5 would be 2000. X equals here, so that would be x equals x equals 15 would be 2010, etc. All right, with me? So that'll just make it. What that does is that makes it. When we get to the equation, we're going to do an equation here. That'll just make the numbers a little nicer. Instead of having these big numbers for x, we can use the smaller numbers. Okay. So this is 0. This is 5. Oh yeah, that would be 15, and that would be 20. Okay. So we're going to use these for our x's, and these, of course, for our y's. All right. So let's use the info. So this is number 1. Use the information from years 1995 and 2010 to find a line that approximates the data. Use the information from years 1995 to 2010 to find a line that approximates the data. All right. So again, we're after a line here. We want a line, and in this particular case, they're going to want the line in function form. And so when I think about a line in function form, we just talked about it, that's f of x equals mx plus b. We've just changed it. It's not y equals mx plus b. It means the same thing, but this is the form they're going to want it. It's f of x equals mx plus b. All right? Now, it's the same thing as before. What we need to do is figure out the m and the b, right? Got to figure out the m and the b. And the way we're going to do that, well, basically we've got, so when you use 1995, the information from 1995 to 2010, well, let's put that information in ordered pairs here. The information from 1995, again, x is 0 is 1995, so the x is 0, 1995, and the y is 32. Everybody okay on that? Mm-hmm. Then from 2010, what have I got? What's the x and y there? Well, I've got the x is 15, the y is 61. So that might help you figure out what we're needing to do here, because to figure out the m, I might have to use the slope formula, aren't I? M equals y2 minus y1 over x2 minus x1. And that'll give me my m. So we'll take the second y, we write out this way, we've got right here 61, minus first y 32, second x 15, minus first x 0, so we've got, what's that, 29? over 15. And, we could leave it as a fraction there, but they'll, I think, want you to decimal, as a decimal. 29 divided by 15. 1.93, approximately. 2 decimal places. So, good on that. So that's our M. So we've got it. Good start here. We've got f of x equals 1.93x plus b. And they chose very nicely for it, or I guess I did chose this one, but what's b here? The y-intercept, which would be where x is 0. Isn't that b? Got x is 0. That's going to be the y-intercept. So if nothing, I mean, if we didn't have the y-intercept here, we could plug in this for x, and this would be our y or f of x. So we could do that, and we could still do that. We could, this is our x, this is our f of x, because f of x is y. But you still get, do it all out here, right? Plug that in for f of x, plug that in for x. That's 0 times 1.93, that's 0, so b is 32, that's what I was saying. I've given you the y-intercept right there. It's 32. So f of x equals 1.93x plus 32. Question or concern? All right. Number 2. Do it here. Second part of this. All right. So use the equation to estimate the waste, awaiting storage, blah, blah, blah. Use the equation to estimate the waste in, let's just do 2020. We're using that f of x equals 1.93x plus 32. I want to estimate the waste in 2020. Well, what have I got? Well, I've got the year. Except x is not per se the year, right? X is 0 is 1995. So I got to figure out what x would be in relation to 1995. So what would 2020 be in those terms? Basically, just subtract 1995, I guess, from that. 25? 25, wouldn't it? 2020 minus 1995, since that's the year basically we started. Is that okay there? So I just need to take 1995 from that, because that's what X is representing. The years from 1995. So that's what I do. I plug in X to be 25. So it'd be 1.93 times 25 plus 32. Just plug in X to be 25. Not 2020, 25, because, okay, 1.93 times 25 plus 32. I get 58.93. Anybody else get something like that?
I got there. I got a different
1.93.
answer.
I got 80.25.
Oh,
Yeah, that's what I got.
I was just checking. We tried again. I may have punched in something. Times 25 plus 32. 80.25?
Yeah.
Okay. I don't know what I punched in first time. You know how it goes. 80.25. Now, technically not quite correct, because the waste, that, 80.25 what? Well, that's where you have to go back to the original statement of the table here. That's thousands of metric tons. So it's not 80.25 tons, it's 80.25 thousands of metric tons. So those are kind of important, right? The units. Is that okay? Question or concerns? Good? All right, got one more type and then I'll be done. All right. Let's do this one. Another one. All right. Frank has started a delivery service. His startup costs are $2,300. He estimates it costs $3 per day. And he charges $5.50 per delivery. All right, so number one. Good on that? Good, yes, you're good. Number one, let's express the cost as a function of x, where x is, of course, the number of deliveries. Because that's what the cost depends on, right? It costs them $3 per delivery. So the cost, of course, would just be, first of all right, so we call it C of X. Let's see, would be okay, I guess, but C of X maybe a little better. But so the cost, what are the costs here? Well, yeah, it costs him $3 for each delivery, right? $3 per delivery. So if he does 2 deliveries, it's $6. 4 deliveries is $12. So as far as that part goes, we're just multiplying, right? $3 times the whatever the X is. However, there's a little more cost involved here, because in fact, to get the cost fully lined out, we had the startup cost too, didn't we? Well, the good news is that's not added on top of each time he delivers. That's just one time. So couldn't we just say, well, $3 times X, then plus the $2,300? That would give us the total cost that the business has accrued. Is everybody okay with that? So that would be the cost, how much it costs for the business at this point. $3 X, $3 times X plus 2,300. Everybody good on that? All right, so number 2, let's express revenue as a function of x, r of x. Again, x is the number of deliveries. So r of x, well, r of x is how much he takes in, depending on the number of deliveries. So what would r of x here? Well, he gets $5.50 per delivery. So that would just be 550 times how many ever deliveries are done? 550x? 550x. That was a little simple. All right. Well, then last, third one here. Determine the x for which cost equals revenue. Determine the x for which cost equals revenue. Yeah, this pretty well sets it up for us. We want the cost equals the revenue, because yeah, that's of course would be where you break even, and so anything after that would be positive, be gaining, have a profit, I guess you'd say, but where the cost equals revenue. So yeah, isn't that what it suggests here? I want to take the cost, $3 x times x plus 230, 2,300. I want to equal that to the revenue, 558. Cost equals revenue. So it just sets up a nice little neat little equation. Easy enough, hopefully, anyway, to solve for x. Does that make sense? So now just solve for x, which in this case I've got x here and x here, so let's subtract the 3x, 100x. For both sides to get rid of it here, so that's 2,300 equals, that'd be 250x. All I have to do is divide by 2. That'll give me my x. See if I can do this right. 2,300 divided by 250. 920? All right, so 920 would be, yeah, where the cost equals revenue, so that would be your break-even point. Cost equals revenue. So, I don't know if they'd ask that, but. All right, question or concern?